Okay, so this is mock question 5. The diagram shows a winch, which is here, which is used to pull a boat 40 metres up the slipway through a height of 5 metres. Use equations from page 2 to answer the following questions. Calculate the gain in potential energy of the boat when it is pulled up to the top of the slipway. The mass of the boat is 1,200 kilograms and the gravitational field strength is 10 newtons per kilogram. So we're looking here for an equation that allows us to calculate potential energy using a mass and using a field strength and possibly using some information from the question. So if we refer back to page 2, looking for an equation that deals with potential energy. Okay, so the change in potential energy is mass times gravitational field strength times the change in height. So we do have the mass of the boat, we're given the gravitational field strength, and in the diagram we're told the height that the boat is lifted up. Okay, so if we quote that as PE equals mgh, okay, so the mass of the boat is 1,200 kilograms multiplied by G, which is the gravitational field strength, which is 10 newtons per kilogram, multiplied by H, which is the height that we're lifting it up by, which is 5 meters. Okay, so if we calculate all that out, we find that that is 60,000 joules. Okay. Now, in addition to that work, that energy required, and that's simply to lift the boat vertically, we also need to be aware of the fact there is 1,000 newtons frictional force acts against the boat as it is pulled up the slipway. Okay, so this is a force that is moving against the boat, okay, and stopping it being pulled up the slipway. Calculate the work done against this frictional force. Okay, so work done. Okay, we could refer to page 2, although we might already know this one. So work done. Now this one isn't stretching, so this doesn't help us really. Okay. So we've got. Okay, so we're expected to know this one. Okay, so work done is force times distance. Okay, so work done equals force times distance. And in this particular question, our force is 1,000 newtons and our distance is 40 meters. Okay, so that's 1,000 newtons times 40 meters, and that gives us the total work done of 40,000 joules. So that's to pull the boat along the slipway. Okay, and then it says calculate the force that must be applied by the winch in pulling the boat up the slipway. Okay, so what we need to do this, we need to calculate the total work done, okay, which is a number of newtons, okay, and then we need to work backwards. Okay, so the work done is 40,000 plus the 60,000, okay, which obviously is 100,000 joules. Okay, and if we take this equation here and rearrange it, because we want to know the force, so work done is force times distance, but we want to know the force rather. So if we rearrange this, if we divide both sides by the distance, then that, so we divide that by distance and this by distance, distances cancel, and we can rewrite that as force is the work done divided by the distance. Okay, so our work done in this case is the 100,000 joules, and the distance is the 40 meters that the boat has to travel up the slipway. Okay, so the force is 100 joules divided by 40 meters, okay, which gives us a force of 2,500 newtons. Okay.